Centering and scaling. So you have, I'm going to use polyfit and I'm going to do the third degree polynomial. Here and penguins, two arrays are there. I'm going to use the same thing, polyfit. Here, I'm going to fit here, comma, penguins, comma, third order. So I'm going to give 3. Okay. Different data we are doing. So I'm going to give 3. I hope it is correct. C is correct. Yes. C is correct. Don't any warning you get, it's not an issue. You can ignore the warning. Only if error comes, you have to worry. Next task you see. You can avoid numerical precision limitation by centering and scaling the data while using polyfit. So if we want to center and scale, that is possible. That's warning you're getting, right? So we can use the same thing. See here, the same command I'm going to use, but I'm going to give within bracket C, comma, build, comma, SC, centering and scaling. Centering and scaling. Okay. So say the polynomial will have a centering information in C and scaling information in SC. We'll see what, I think now without warning, we will have the polynomial. See, previously when we executed, we had some issues with the polynomial. So, but now that is overcome by using the centering and scaling information. So, centering means it will say it is centered around where, and scaling means I am just multiplying each value by 10 power 3 into what number that is given by centering and scaling. Now, use the poly-eval function to evaluate the polynomial. So, when you use the poly-eval function, you have to give the centering and scaling information. So use poly-eval function to fitted polynomials. So, fitted C, comma, SC. And I am going to give the same here, and I am going to rename the variable penguin fit. See here, whatever C and SC we got in the polynomial, we have to use the polyval function also. The polyval of C, comma, x is here, and here this command is empty. The third one is empty because we don't use anything here, right? That is empty, and SC is the scaling information. Yes. So we have evaluated the function, and maybe we can plot here, comma, penguins. Okay, hold on. Plot here, comma, penguin fit, comma, I'm going to plot in red color. Hold off. We'll see whether we are getting both the graphs in a single thing. So the blue color is the actual data and red is the fitted data. Okay, red will cover both the data. So you can see the variation of actual data above and below red, and red is the actual data. Okay, so red is going to be the actual data. Okay. So polyfit and poly-eval functions are used in MATLAB to generate a polynomial which is going to fit your data between the x and y axis values. Okay, so it is going to do that easily for you.